Okay, so let us start with the next part of module 3, that is fuel cells. Okay, write down fuel cell. So the definition of fuel cell will be asked for 2 marks. Okay, so what is fuel cell? So in order to understand the definition of fuel cell, let me divide this fuel cells into 2 words, fuel as one word and cells as another word. So cells here, it means cell is nothing but a galvanic cell. So the cell here indicates it is a galvanic cell. And what is meant by a galvanic cell? The one which converts chemical energy into electrical energy, right? So galvanic cell is the one which is going to convert chemical energy into electrical energy. So this is with respect to cell now. So then what is a fuel? So fuel is the one which is the active component here. Okay, in case of fuel cells, fuel is the active component and this is going to undergo oxidation. Okay, how it is going to undergo oxidation? In presence of what? In presence of oxygen. So oxygen will be the oxidizing agent. So oxygen is going to oxidize the fuel and itself will get reduced. Oxygen will oxidize the fuel and itself will get reduced through a combustion reaction. So fuel is the active component which is taken at the anode. So fuel is going to undergo oxidation in the presence of oxygen. Oxygen is the oxidant which is taken at cathode, and cell here indicates it is a galvanic cell. So compiling all these together, how can I define fuel cell? So fuel cell is defined as a galvanic cell in which the electrical energy is directly derived by the combustion of chemical fuels which is supplied continuously. Okay, write down. Fuel cell is defined as a galvanic cell. Okay, it is a galvanic cell. Yes. And what is galvanic cell going to do? It is going to convert chemical energy into electrical energy. And this process is going to take place directly. Okay, so direct conversion is going to take place. How? Through the combustion reaction of the chemical fuel. And chemical fuel is supplied continuously from outside. So this is what is fuel cell means. So fuel cell is defined as a galvanic cell in which the electrical energy is directly, underline the word directly, derived by the combustion of chemical fuels which are supplied continuously. So this is what is meant by fuel cell. So why I said to underline the word directly? As the direct conversion is going to take place, the efficiency of fuel cell will be more. As the direct conversion is going to take place, the efficiency of the fuel cell will be more, better compared to that of the conventional batteries. Okay, efficiency wise, these are better because direct conversion of chemical energy into electrical energy through the combustion reaction is going to take place. So next, how do we represent the fuel cell? So this is the one. So we have 2 electrodes. One electrode is at anode, another electrode is at cathode. In between them, we have the electrolyte. Okay, so we have anode and a cathode electrode. In between them, we have the electrolyte. And fuel, which is the active component, passed near the anode. Fuel cell is passed or it is supplied near the anode. And oxidant means what we are using? We are using oxygen, and this oxygen is supplied near the cathode. So oxygen is the active component at cathode, fuel is the active component at anode, fuel is supplied near the anode, and oxidant, that is oxygen, is supplied near the cathode. So this is the overall cell representation. So we have anode, we have cathode. In between them, we have the electrolyte. Electrolyte we need to select in such a way that it has to catalyze both the anode reaction as well as the cathode reaction. Okay, So we have to select it in such a way that it has to catalyze both the reactions. And fuel is supplied near the anode and oxidant is supplied near the cathode. So I hope now you understood a little bit about fuel cell. So at anode, what kind of reaction is going to take place? We know that anode means oxidation reaction will take place. Means we are supplying fuel here. So fuel, which is the active component near the anode, is going to undergo oxidation. So on oxidation, what it will give? Fuel will release n number of electrons with the oxidation product. So oxidation means releasing of n number of electrons. So n number of electrons are released along with the oxidation product through this fuel at the anode electrode. And what happens at the cathode? Cathode means reduction reaction. And what is present at cathode? Oxygen, which is the oxidant. So oxidant means what? It will oxidize others and reduces itself. So how the process is going to take place? With the gain of electrons. So oxidant will gain the n number of electrons which are released from the anode, and then it will give us the reduction product. Okay, fuel will undergo oxidation, oxidant will undergo reduction. Fuel will release the n number of electrons and oxidant will gain those electrons, thus giving the reduction products. Understood? Next one is difference between conventional cell and fuel cell. So what is the difference between batteries and the fuel cells? So this can be one of the important question for 5 to 6 marks. Okay, so what is the difference between conventional cell, that is a battery, and a fuel cell? So what is a battery? A battery, it is a device consisting of 2 or more galvanic cells, and these galvanic cells are connected in series or in parallel or both, right? Battery means it is a device consisting of 2 or more galvanic cells which are connected in series or in parallel or both. So that is battery. What is a fuel cell then? So it is also a galvanic cell. Yes, it is a galvanic cell in which the electrical energy is directly derived by the combustion of chemical fuels which are supplied continuously from outside. Okay, it is also a galvanic cell, and here also we are getting the electrical energy, and we are getting the electrical energy directly through the combustion reaction of the fuels, and these fuels are supplied continuously from outside. Okay, so that is fuel cell. And batteries, yes, they are the storage devices. So definitely batteries will store the chemical energy. And fuel cells, no, they do not store any kind of chemical energy. Okay, batteries will store the chemical energy and fuel cells do not store the chemical energy. And what about the reactants? In batteries, reactants are stored inside the cell, right? All the active components which are in the form of the reactants are stored within the cell in case of battery. But here, the reactants, that is the fuel and the oxygen, are supplied from outside. So in case of fuel cells, the reactants are supplied from outside. Okay. And what about the electricity generated? So in case of batteries, the electricity is generated as long as the active materials are present inside the cell until they exhaust. Electricity is generated. As long as the active materials are still present, electricity is generated. And once the cell exhausts, the active materials exhaust, then only the cell will become dead. But here that is not the case. Fuel cells, electricity is generated as long as the fuel and oxidant are supplied from outside. So if we are supplying from outside, then only the electricity is generated. Once we stop the supply, electricity is cut. Okay, so as long as fuel and oxidant are supplied from outside, electricity is generated, and when we stop, it will stop. And what about the products? In case of batteries, for example, we have lead acid battery, we have nickel cadmium battery, lead, cadmium, these are toxic substances, right? So batteries will contain toxic substances. They are not eco-friendly, and the products which are formed can also be toxic in nature. What about fuel cells? Combustion is going to take place. What does the fuel consist of? It consists of carbon and hydrogen. And what about the combustion products? When carbon undergoes combustion, we'll get carbon dioxide. When hydrogen undergoes combustion, we'll get water. So carbon dioxide and water are safe products. They are eco-friendly. So no toxic chemicals are produced. Okay, because the products formed are normal combustion products. They are safe. Whereas in battery, they are toxic. So let us come back again. So what is a battery? It is a device consisting of two or more galvanic cells which are connected in series or in parallel or both. What about fuel cell? It is a galvanic cell in which the electrical energy is directly derived by the combustion of chemical fuels which are supplied continuously from outside. And batteries will store chemical energy, whereas fuel cells does not store chemical energy. And reactants are stored inside the battery within the cell only, whereas here in case of fuel cells, reactants are supplied from outside. And the electricity is generated as long as the active materials are present in the battery. Until the exhaust, the electricity is generated. Whereas here, the fuel cell case, electricity is generated only as long as we supply the fuel and oxidant outside, from outside. Once we stop, it will not continue. Okay. And what about the toxic products? Batteries do contain some of the toxic substances like lead, cadmium, etc. Whereas the chemical products which are formed from the fuel cells are safe products. They are non-toxic. Hence, we can say fuel cells are eco-friendly. Okay. Okay. So next, what are the advantages? What are the advantages of fuel cells over batteries? So high efficiency of the energy conversion process. From fuel cell, we can expect high efficiency. How high efficiency is observed? Because the direct conversion is going to take place. As the direct conversion from chemical energy into electrical energy is taking place, so we can expect efficiency to be higher. Okay, and then no moving parts. So the parts are not at all, we are not changing or we are not moving any of the parts. So elimination of wear and tear. Okay, so elimination of wear and tear means with daily normal usage, no damage will take place. As the parts are not movable, any kind of damage will take place to the parts as they are non-movable. So with daily usage, nothing like wear and tear doesn't take place. Damages and all will not take place. And operation is silent, and absence of harmful waste products. Exactly, I said that we are getting the safer combustion products like carbon dioxide and water. So harmful products are not at all present in case of fuel cells. And what about charging? No need of charging. And moreover, we cannot charge also because the reactions are irreversible here. If we want it to be recharged, then the reactions have to be reversible. Okay, so the discharge reactions and the charging reactions should be reversible. Whereas in this case, the reactions are irreversible. Say, for example, I have a fuel containing carbon. Carbon on combustion will give me carbon dioxide. Is the reaction reversible? No, it is irreversible. So we cannot recharge. And by the way, no need of charging is required in this case. Okay, and fuels used are not expensive. Okay, so these are the advantages of fuel cells. And there are limitations. So power output observed from fuel cells is moderate. So it is like 1.2 volt or 1.3 volt compared to batteries. Say for example, lithium ion battery will give us 4.5 volt. So compared to batteries, fuel cells output is little bit less. But we can sort out this. How? Single cell will give us less output. We'll connect to multiple cells, we'll stack cells together in series. Then we can increase the power output. Okay, so this we can overcome by stacking many cells together in series. Okay, single cell definitely its power output is less. And what we are using here, we are using fuels in the form of gases, and also oxygen we are using. And how we are going to store this? We are going to store them in tanks. And storing in tanks under high pressure is little bit risky. Okay, so this is another kind of limitation. Fuels in the form of gases and oxygen has to be stored in tanks under high pressure. So this is another limitation. Is this clear? Advantages and limitations? Yes? If yes, then I'll go for the next part. So whatever the introduction I gave you about this fuel cells till now, is it understood, students? Please answer in the chat box. Okay, so next comes a very important question, that is methanol oxygen fuel cell. Write down. So this question is one of the definite question for your exams. So that is construction, working and applications of methanol oxygen fuel cell. Write down methanol oxygen fuel cell, and this can be asked for around 6 marks. Okay, so we need to draw the diagram. We have to explain the construction of the cell, and then we need to explain the working with the anode reaction, with the cathode reaction, and with the application. So if application is asked, then the question will be for 7 marks. Otherwise, it will be for 6 marks. Okay. So construction, working and application of methanol oxygen fuel cell, and the electrolyte used here is H2SO4, acid electrolyte, sulfuric acid. So let us go to the diagram. Okay, I hope the diagram is visible for you all. So what does this methanol oxygen fuel cell consist of? So methanol oxygen, which is the fuel, do you think? Definitely, methanol is the fuel. And which is the oxidant here? Oxidant is oxygen. Definitely, oxygen is the oxidant. And methanol has to undergo oxidation, and it will go oxidation in presence of oxygen. So definitely fuel is supplied at the anode and oxidant is supplied at the cathode. In between them will be having the electrolyte, and the electrolyte used here is sulfuric acid. Okay, so you can see this diagram. We have a anode here, right? And we have a cathode here. So this anode electrode and the cathode electrode, these both are made by platinum. So anode and cathode are made up of platinum electrodes. So they are made up of platinum. Okay. And then in between them, we have taken the electrolyte, that is H2SO4, sulfuric acid. And from this end, we are going to supply the fuel, and its product will go from this side, that is bottom. And from this end, that is from the cathodic side, we are going to supply the oxygen, which is the oxidant, and its product will go out from here. And one more thing that we can observe here is, close to cathode, we have placed one membrane. So you can see a line drawn here near the cathode electrode. So this line is a membrane. So membrane is placed near the cathode. So construction, I hope you understood. We have two electrodes, anode and cathode, which are made up of platinum. Okay, and fuel is circulated. Fuel is nothing but the methanol mixed with H2SO4. We are supplying at the anode compartment, and oxygen, which is the oxidant, is passed through the cathode compartment. And sulfuric acid is used as the electrolyte. Both the anode and the cathode electrodes are made up of platinum. And a membrane is inserted near this cathode. Why we have inserted this membrane? So this membrane is inserted in order to prevent the diffusion of methanol towards the cathode. So methanol can enter like this, can cross anode, can diffuse through this electrolyte, and then can reach cathode if membrane is not present. So methanol can diffuse like this through the anode, through the electrolyte, and through the cathode, and then react with this oxygen and can undergo oxidation. So we don't want that to happen. We want to restrict the concentration of methanol near the cathode. We don't want it to reach near the cathode. So in order to restrict the concentration of methanol near the cathode, we have placed this barrier in the form of membrane. So in the absence of membrane, what will happen? Methanol will come like this. It will cross the anode, it will diffuse through the electrolyte, and then it will reach the oxygen and it will undergo oxidation. So in order to avoid that, what we are doing? We are keeping a barrier in the form of a membrane so that methanol will not reach the cathode and it will not react with the oxygen. Okay. So now, what are the reactions? So definitely at anode, we have methanol. So anode means oxidation. And at cathode, we have oxygen. So oxygen will undergo reduction. So what is going to happen here? I hope it is clear. So methanol will undergo oxidation. What is the oxidation product of an methanol? That is alcohol. Alcohol on oxidation will first give us aldehyde. And with further oxidation, it will give us carbon dioxide. So methanol will first give us formaldehyde. Formaldehyde on further oxidation will give us carbon dioxide. So here I'm showing directly methanol is going to give us carbon dioxide. And anode means liberation of electrons has to take place, right? So it is liberating 6 electrons. 6 electrons are being liberated. So what is the charge on this side? It is neutral. I mean, it is 0. Whereas here, what is the charge? I got 6 negative charge in the form of 6 electrons. So I have to neutralize, balance the 6 electrons. So in order to balance that 6 negative charge, I'll add 6H plus. So this is H, okay, 6H plus. To balance the 6 negative charge here, I'm adding 6H plus. I don't have any other option. I have to add either H plus or OH minus in order to balance the charge. And I cannot add OH minus here because the electrolyte used is acid. I'm not using alkali as an electrolyte here, so I can't use OH minus. So the only option for me, as I'm using acid as an electrolyte, is adding 6H plus to balance this charge. Okay, so methanol on oxidation is going to give us carbon dioxide with the liberation of 6 electrons. Anode reaction is clear? And to balance the 6 electrons negative charge, I'm adding 6H plus. Now these 6 electrons are gained by the oxygen. Okay, oxygen is present at cathode, so this will undergo reduction by gaining these 6 electrons. So again, same thing, to balance this 6 electron, I'm adding 6H plus. To neutralize the charge, 6 negative charge, I'm adding 6 positive charge in the form of H plus, as I'm using acid as the electrolyte. Okay, and what is the product? It is H2O. So now 6H plus 6H plus will get cancelled. 6 electron will get cancelled. And here I have 1 H2O and here I have 3 H2O. So 3 minus 1 H2O, I'll get 2 H2O. So the overall reaction is methanol plus 3 by 2 O2 will give me carbon dioxide plus 2 H2O. Okay, so write down the reaction. At anode, methanol will undergo oxidation and forms carbon dioxide with the liberation of 6 electrons. To balance this 6 negative charge, I am adding 6H plus. As I am adding H plus, on this side, to make the balance of hydrogen and oxygen, I can add water. Okay, that is the only way. And then whatever the 6 electrons are liberated at the anode are gained up by the cathode. That is oxygen which is present at cathode. And to balance this 6 negative charge, I am adding 6H plus. And the overall product obtained at the cathode is water. So 6H plus, 6H plus, 6 electron will get cancelled. And what I left up with in the overall cell reaction is methanol will undergo combustion in the presence of oxygen, that it will undergo oxidation and give me the safe combustion products, the non-toxic products as carbon dioxide and water. Okay. So what is the EMF produced by the cell? It produces an output of up to 1.2 volt at 25 degrees centigrade. So I can get an output of 1.2 volt. Okay. Now, why did I use acid as an electrolyte? Why didn't I use alkali as the electrolyte? I would have used alkali, right? What is the reason why we are avoiding using alkali as the electrolyte here? Why we prefer to use H2SO4 only, that is acid only as the electrolyte? Why not alkali? The reason is, what is the product formed at anode? Carbon dioxide, right? Carbon dioxide is the byproduct which I am getting. So this carbon dioxide will not react with acid, right? So it doesn't react, carbon dioxide will not react with H2SO4. But if I use NaOH, carbon dioxide can react with alkali and get precipitated in the form of carbonate. So if it precipitates in the form of carbonate, how do I remove that precipitate from the system? It becomes very, very difficult. Whereas if I use H2SO4, it will just easily live in the form of gas. Carbon dioxide will easily get out of this system. It can be easily removed. But in case if I use NaOH, at that time, carbon dioxide gets converted into carbonate in presence of alkali. I hope you understood. Okay, the use of alkali as electrolyte will create problem. So what is that? Carbon dioxide produced during the reaction, it is absorbed by the alkali electrolyte and it will get precipitated into its carbonate. Then its removal will become difficult. And what is the advantage of using sulfuric acid as the electrolyte? The reason is carbon dioxide, which is a byproduct, will not at all react with the acid and hence it can be easily removed out from the system. So this is the reason. Did you understand? Finally, what is the application where we can use this kind of methanol oxygen fuel cell? So we can use it in military applications. We can use it in military applications and also we can use it in large scale power productions. So it has its application in militaries as well as in case of large scale power productions. Is this understood, students? So this is all about methanol oxygen fuel cell. Okay. Is it clear? Did you all understand? Let me take the attendance. Okay. Any doubts? If you have any doubts, please ask me. So in tomorrow's class, we'll deal with solid oxide fuel cell. Another important question. Okay. So did you understand? Did you understand the reaction? Did you understand the construction? Did you understand the overall mechanism behind it? Okay. And the electrodes which we are using, platinum, they are the inert electrodes. Okay. So the electrons are going to transfer from the electron rich platinum through the electron to the electron deficient platinum. Okay. So here it is going to act as a catalyst near anode and here it is going to facilitate oxygen to undergo reduction. So that is the purpose. Is it understood? Okay. Fine then. Thank you.